Hi everyone, my name is Bo Wu. Welcome to my video channel. Today I'm going to talk about my ECE 570 project, which is enhancing image generation with self-attention mechanisms. Let's briefly talk about the paper I reviewed and my motivation on extending the paper. We already learned GAN, which is a class of machine learning, and I'm quite interested in learning how does GAN help on image generation. Although GAN is a powerful innovation, it still has some limits on capturing remote dependencies, and this may cause damage in image generation, like low quality and unclear in some details. Researchers have tried some new techniques like SAGAN to enhance image generation. It is quite effective, but it cannot solve the problem itself for GAN. So the paper introduced a technique called SAGN, which is using self-attention in generator and the discriminator of the original GAN. The incorporation of self-attention into both the generator and discriminator allows SAGNs to capture long-range dependencies and subtle relationships within images, resulting in higher quality generated images with improved global coherence and fine details. Moving on to the implementation preparation, let's break down the key steps. First of all, I used Python 3.6 and TensorFlow 1.5, which followed the request in the original repository. The codebase is also from the official GitHub of this paper. Lastly, I downloaded the datasets from the ImageNet website, and then using the improved GN repository to convert them into TF record files, so that I can run it using the SAGN model. Now let's delve a bit deeper into the implementation details. The code is built on the original SAGN code, and I also used the improved GN GitHub to convert datasets. But there are some modifications to specific files, including generator and discriminator, and also a model file to choose the function I added. You can see the code above is discriminator hyperfunction. I introduced some new variables like block layers, use non-local, and so on to improve the performance. Let's move on to the results and what they mean. The positive results include improved visual quality of generated images using SAGN. You can refer to the example image on the right. This is the image I used the SAGN with hypergenerator and discriminator I modified. As you can see, the image is quite clear in capturing details. For the negative results, that SAGN cannot generate diverse outputs, especially with complex features, but overall the results can meet my expectations. In summary, extending the SAGN paper can generate positive outcomes on capturing remote details on image generation, but the challenge is also exists in complex features. In the future, we should explore more on this data and try to solve the problem. Last but not the least, this paper helped me understand the SAGN behavior, and now I'm more interested in other GAN variants, and I hope I can explore more in the future. Thank you for watching this video.